Okay, so hi. So thank you for watching this video. So in our first video, we just mentioned some main topics of the contents of mathematical statistics from this textbook. So from the contents, we can say chapter 1 is about probability, and chapter 2, random variables, is about distribution. So we say distribution is just put all probability together, or just check all cases, right? So this is distribution. So for distribution, so we have some typical, we have discrete distribution and continuous distribution. So here we imagine some typical distributions. For discrete distribution, we have binomial distribution, Bernoulli distribution. The Bernoulli distribution just a 1-0 distribution, like try one time. So if you try many times, then we have binomial distribution, right? Then we have a geometry distribution. So this is a typical discrete distribution. And for continuous distribution, we have exponential distribution and gamma distribution, and the typical situations of normal distribution and also beta distribution. So and for chapter 3 is joint distribution. Joint distribution is we have 2 variable or 3 variable, many variable distribution. Okay, so for joint distribution, we also have 2 cases: discrete situation, say like discrete 2 variable distribution, or continuous 2 variable distribution. So we also can have like a 3 joint distribution for 3 variable, right? For many variable, but the basic thing is the 2 variable. So if we have 2 variables, then we will measure their relationship. So we call this a correlation and covariance, right? Okay, and so chapter 4 is expectation. So from distributions, we can find those two important numbers. First one is mean or expectation. Second one is variance. So take a square root of variance is standard deviation. So mean, variance, and standard deviation. So we have so many distributions. So for each distribution, we can find mean, standard deviation, and variance, those things, right? Okay, and for 2 variables, we have covariance and correlation, right? And for 2 variables, many variables, we have a conditional expectation and conditional standard deviation, like conditional variance. So conditional meanings we just check a typical situation. We just focus on, if we have 2 variables, we just let one variable is fixed, then only let the other one change. So those distribution is conditional distribution. So from any distribution, we can find the mean or find the expectation and the variance, right? So we have a conditional expectation and a conditional variance, right? And chapter 5 is limit theorem. So limit theorem is essentially limit theorem. Okay, So central limit theorem basically many things follow normal. So in statistics we have this like x bar follow normal, right? Or close to normal. We have this result. Okay. So this is just the central limit theorem. Okay. Okay, so we can say from chapter 1 to chapter 5 are basically a probability issue. A probability, those distributions, those things. So those materials have lots of overlap for actual exam 1. Actual exam 1. So sometimes we call this exam P1. P stands for probability. So I hope if you have some interest, then you can try to prepare for this exam. So if you pass this exam and there's actual exam P1 and exam P2, if you pass these 2 exams, maybe you can find some job for actually. So actually, this job is good, and the pay, the salary is high. Okay. Okay. So then we can say from chapter 6 is about mathematical statistics. So we can say from chapter 1 to chapter 5 is just the preparation, just the probability. Okay. Okay. So let's say for so I let's see so for exam like actual exam P1, I put some materials on my website. We have so SOA's Association of Actuary. So their website have lots of information about those exams. And for typically for exam P1, they have some sample problems, and I make some lecture videos for those sample problems and review overview problems. So we can say like for this exam P1, they just have those materials like okay, just the probability distribution, like 1 variable distribution and 2 variable distribution. Okay, just those things. And so here like we have the probability, right? So distribution, so 1 variable discrete distribution. So 1 variable discrete distribution. So we have two values. And so then 1 variable continuous, right? So for 2 variable, we have 2 variable discrete distribution and let's say no, should have like no, should have 2 variable discrete situation and 2 variable continuous distribution. Just like distribution, we have 1 variable, 2 variable, right? So for each kinds, we have a discrete and continuous. So those are just let's say we should have 2 variable continuous distribution. Okay. So here 2 variable discrete, we have 2 variable continuous. Okay. So those are actually the material for exam P1. So for exam P1, they provide some sample problem. So we can put I found before it works, but by now, so this PDF file maybe not work. So if you have some interest, not sure. By now I don't know why. Okay. So if we have some interest for those actual exam, you can check my lecture notes and check my lecture videos, or you can email me if you have any question. So I find some of you have some interest for those actual exam one. Someone do not have interest for this. So I consider to spend to spend half a semester for mathematical statistics. Math stat. Then actual exam one. Exam one. Okay, so we say here is the half semester. So okay, so here also other half semester. Okay, so after the half semester, I will give you an exam saying give you a grade, so you are done. So if you have some interest in preparing for actual exam, so we can discuss those topics for the remaining half semester. Okay, so we say half semester for math stats, half semester for actual exam. Okay, so if you do not have interest in actual exam, you are done, right? So half you are done. Okay, because you already have this grade. Okay. Okay, so for mathematics, so we say mathematical statistics will include those materials. It seems we have many, but basically we just try to answer some questions in applied statistics. So in applied stats, we say actually we have we have normal distribution. We have z table, or z standard normal, like z table and t table, t distribution and f distribution and chi-square distribution. So we say all of them just come from normal. So we say from this, just get this, and all we can say like all other distributions just come from normal. So we will understand why normal distribution is so important. So the reason is because many things themselves are normal. So the other reason is we have a centrally limited ceiling. Other reason is some other distribution were close to normal. A typical example is binomial distribution. Binomial distribution will close to normal, right? Will close to this normal. Mean same NP, standard deviation NPQ. So binomial distribution will close to normal. So we call those things as centrally limited ceiling. But in applied stats, we just use them. We use this result. We do not prove them. This, right? So in mathematical stats, we will prove this. So this question how to prove CLT is a big issue in mathematical stats. Okay. Okay. So in mathematical stats we know we say in statistics our purpose is just to try from try we from the sample we let's say so here so try from sample from data we want to get in some information from population. So here this is population. So from the population is huge, we cannot check all of them, so we just pick some. So we call this is a sample. So sample is data, right? We have those numbers. Then from those data, from the sample, we can find the sample mean and sample standard deviation. And so basically we use sample mean. So for estimation, so we call this as estimation. From a sample, go to from population, take a sample. Then from sample to estimate some information for population. So we call this estimation, right? So for example, so for population, we have average for population. So this average is mu. And we also have changement among the population. We have sigma. So this mu and sigma we don't know. But from sample, we can have samples mean. So we have x bar, samples average, samples mean, and we have samples standard deviation. So we can say how to estimate this mu. We say use sample mean to estimate the population mean, and this sigma we use samples standard deviation to estimate population's standard deviation. Right? So we have this formula. Like x bar is just the x1 plus x2 plus xn divided by n. So just average, right? And so for sample standard deviation or samples variance, we use this formula, right? x1 minus x bar square plus xn minus x bar square, then divided by n minus 1. So we have those formulas. So in applied stats, we just use those formula. Okay, just use this formula. So in applied stats, we want to answer why or how. Let's say how to get those formula. How to drive those formula. And we also, so we can say like here, y divided by n minus 1, not divided by n. So the answer is because divided by n minus 1 is better than divided by n. So what better meanings? So in general, for any parameters in population, how to estimate this? So here we have mu. How to estimate this mu? So we say we use x bar, and this x bar is best one. Like why use x? Why we do not use this one? Like let's say we just we also can use this. Like if we have n number, we just can we just use x1 plus x2 divided by 2. Use this. Estimate this mu, right? This is also average. So average for those two numbers, and it's here average for those n numbers. So why this average for n number is better than average for those two numbers? So we want to explain like what best meanings and why this is best, right? And for a in general for a parameter, like for a mu, like how to find the best estimate for this mu. So we will discuss those things in applied stats. Okay. And we also say like in statistics we have the 4 tables: C table, T table, F table, chi-square table. So here we know Z, right? Standard normal. So we want to understand what the TF chi-square meanings, and where those things come from, and how to derive their mean and standard deviation. Okay. So like where does the T distribution, F distribution, chi-square distribution come from? How can we find their density function and their mean and variance, those things? So I think those are some main topics in mathematical statistics. Okay, so we just in mathematical statistics, so we will focus on first one, proof. Let's say proof CLT. Okay, this is first question, and then we can this proof CLT. Okay, and then we will we were talking about how to estimate population things. So populations, so some index we call populations parameter. How to estimate the population's parameters, how to estimate mu, how to estimate the sigma. Okay, so we put this as a question 1. Here's question 2, and then we will check question 3, where those come from. So how can we derive those their density function, or how to derive their mean and standard deviation for those distributions? So in order to do that, we need lots of mathematics. Like typically we need one variable integration, two variable integration, variable transformation, those things. We need integration and derivative, those things. Okay. Okay. So for our next class, maybe we can focus on this first question. We want to prove central limit theory. Okay. 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 So so this short video we can regard as our second class. Okay. uh, so again, like I say, like we split into, let's say, half semester. So for first half we will focus on mathematical statistics. Okay. For second half we will focus on actual exam, P1. So if we have interest in actual exam, so we will discuss those things in the second half. So if you do not have interest in those actual exams, so you you are we will finish this material for the first half semester. Okay. Okay. So we can stop here. Thank you for watching.